All right. So without further ado, hopefully you can see today's workshop is on XSS and CSRF, which stand for cross-site scripting and cross-site request forgery, respectively. Okay, so just sort of as an introduction, if you're not aware, OWASP is the Open Web Application Security Project. Every 4 years, they make a new top 10 list of the top 10 web application vulnerabilities that app security specialists have found. And so, as you can see, in 2017, cross-site scripting was 7th out of the top 10 of like all the web app vulnerabilities that people have discovered. And it's moved up together with injection. Injection usually refers to SQL injection, which was last week's workshop, but now they're combined. Since, as you'll see, XSS is kind of an injection. And now they're combined and they're still third. So pretty big deal. So if you're following along on the slides, here's a quick introduction just to how accessing the web works in general. So let's say we have little Timmy here, and he graduated 5th grade, so his parents bought him a computer. And Timmy really likes watching Minecraft speedruns. So he's going to go to YouTube on his computer. And so his computer is going to make a request to YouTube. YouTube is going to go through its server and find the video Timmy wants and send it back to him. And so let's say Timmy really enjoyed the video, and so he wants to leave a comment, right? Oops. And so he's going to send his comment to YouTube. YouTube's going to leave it in their server. And the important thing to remember about Timmy's comment and how it works with the server is that whatever Timmy said is stored in the server. And anytime someone goes through the comment section, their browser is going to get some raw data from YouTube in the form of JavaScript, HTML, CSS, and it's going to render in their browser for them, right? And so, yeah, I mean, not much to say about that at this point, but remember that for the future. Okay, and then another important thing to remember is that like Timmy's using a browser and the browser is accessing the web through what are called HTTP requests. It's not that important that you know exactly what an HTTP request is. It's just important that you know that it's not something that's super special, and any website, any object that has access to the internet can send an HTTP request to any website. So any website can send an HTTP request to any other website. And for example, that's kind of how you see YouTube videos like within Discord. There are some restrictions. There is something called the same origin policy, and there are exceptions to these restrictions. But the main thing to remember is that any website can send a request to any other website, but different domains can't share private user data. So you can send a request wherever you want, but you won't always get a response back, depending on what you're asking for. And then, of course, an important thing to talk about anytime we're on the web is JavaScript, right? So JavaScript, in case you're not aware, is how you make a website have dynamic functionality, right? So if you want a user interacting with your website, clicking on things, changing how it looks for them, you need JavaScript. 2 other important things that JavaScript does is it keeps track of your cookies, which are stored in your browser. I'll get to the cookies in a second. And JavaScript can be used to manage the cross-site activity. So in particular, this fetch function in JavaScript can be used to send HTTP requests basically wherever you want. And then just in this little picture here, 3 general ways that you can use JavaScript. It can be inlined in the script tags. You can load it from another source. So that's how you would get it across different pages within your own website. You can get it across different pages on the web. And then also you can use it in different objects and event handlers, like a button on click can cause some JavaScript to run. Yeah. Can you talk more about the fetch function? I don't really understand. Yeah. So I guess going back to HTTP requests. So anytime you want something from a website, your computer or your browser will put together just like a big list of things that are important for the website to know, like who you are, what browser you're using, what kind of device you're on, what information you want, and things like that, and it'll send it to the website, right? And the website processes the HTTP request and sends back a response. And basically what the fetch function does is it's going to go ahead and take all of the necessary information from your browser, like your cookies, whether you're using Chrome or Firefox or Internet Explorer, and whatever information you specify within the fetch parameters is going to be sent in an HTTP request to whatever destination you specify in the parameters. I will show an example where we use fetch. So if you have any more questions after that, feel free to ask again. And then cookies, probably the most important thing for web security. So you might notice, like when you're accessing a website, they seem to have a lot of information about you, and they have a lot of information about everyone, really. And it wouldn't be possible for them to store all of this information in their own servers. So for things like authentication, like how you stay logged in for a couple hours at a time, how it keeps track of your shopping cart over multiple visits to the website, how if you look up some item on Amazon and then see ads for it across all the different sites you go to, that is all cookies, right? And so basically, the important thing to remember about cookies is like, this is usually the only way that a website knows who you are, right? So this is very important. If someone gets your cookies, they can basically commit like online identity fraud. All right.
The time has come
Okay.
for this cookie. Nom, 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 nom. Oh, nom, 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 nom. Bye-bye.
Okay. All right. So now we're just going to do a quick demo. This is on my own github.io. Let's see. Okay, so if you want to follow along like on your own, feel free to do that. You should be able to. There shouldn't be anything stopping you from seeing this. Basically, what's going on here is we have a large input field, and you can see if I type something in there and click update, it just shows up down below, right? So anything that takes user input and renders it back to you, stores it in the server and renders it back to other people. This is why it's important that Timmy's comments were stored in the server and rendered to everyone who sees them. Anything that takes user input and renders it to other users is a possible victim of cross-site scripting, right? So, oh wait, should we check the chat? Okay. Okay, so since this takes user input and renders it back out to us, it is a possible victim for cross-site scripting. But at currently, I'm just gonna take like maybe some audience suggestions. Is there anything you want me to type into this box and then update? Sure.
Type like an inline script tag.
Sure.
And then inside of it, have it alert hello.
Okay. Okay, so we're kind of getting right into maybe what might be the final goal here. So I'm going to go ahead and click update and we'll see if anything happens. Okay, so unfortunately, nothing happened there. Usually this is a pretty basic cross-site scripting vector. We can maybe take a look at inspect element and see what's going on. And so let's go ahead and expand the head and the body. So we can see there's a script in the head. Let's go ahead and see what this is doing. So there's this update function. And if we look, it is being called anytime we click the button that says update, right? So it looks like there's some random information, a cookie's being set. We'll get to that in a second. But the important thing is this last line of the function is changing the inner HTML, right? And so maybe you guys are familiar with this and maybe you aren't, but the inner HTML actually ignores script tags. So on top of this, just taking user input, it does implement a basic filter. But as you might remember from the slide where I showed how you can include JavaScript in a web page, there are, wait, what happened? Oh, Jerry. Thank you, Jerry. Okay. There are other ways to include JavaScript in your page, right? Does anybody have anything else they want me to put in here? Doesn't even have to be JavaScript, just whatever you want. If you want to see it on the screen. No? Anybody? Yeah, Benson. Anything you want me to type in particular? Okay. All right, we can go ahead and update that. And that just shows up as is. Josh, did you have something? Just poop? Yeah. Okay. Anybody else? Yeah.
Wait, so if it ignores script tags,
Mm-hmm.
maybe you could try using something that's not a script tag, but also executes JavaScript.
Okay, and
So
anything in particular?
you could do like a button, and
Mm-hmm.
then you could do on click equals, and then inside parentheses, you could type in some JavaScript. So like just a word.
Sounds good. And then just for anyone who is not familiar, when you're doing something in HTML, you can use these different commands, like I'm using and quote here to get the quote inside the quotes around the hello. But yeah, this may be important in the future. Maybe a spoiler, but go ahead and update that. Oops. Wait. It should be working. Okay. Okay, so yeah, we've added this button and we haven't done anything to it yet, but what happens if we click it? So when we click it, we get a pop-up that says hello. And so that means that anything we do in this on click is possibly XSS, right? So anything that executes in your browser on your computer has access to all of your cookies. So one thing that I'm going to do right now is just going to go ahead and change this. I'm going to go ahead and change this alert to something that would show your cookies, right? So if you want to get your cookies out of JavaScript, you can use this command document.cookie. And so if I go ahead and update it again and then click the button, you see that in the pop-up, we get secret number equals 76, right? So that's telling us that in the whole update function, it set our secret number cookie to 76. And that was what the whole cookie thing is doing. But like, what if an attacker is on this site and like, maybe just use your imagination for a second, because I didn't want this to be like an actual vulnerability on the web. But imagine like you update it and it updates for everyone. Like this goes to some server and everyone who's seeing this site also sees what you're typing, right? So then everyone who clicks the button will get a pop-up with their cookies in it, right? But it's not much use to the attacker if the cookies are just showing up on other people's screens. You want to know their cookies, right? And so that's where fetch comes in, right? And so for XSS and especially for our challenges, you can use this thing called postbin. Postbin is just like sort of a pretty generic bin. You can make one. So I'll just make one right here. And what you can do is you can send any kind of HTTP request to it. It's not going to do anything with it, won't send back any responses. But what it will do is it will show you all of the data that got sent in the HTTP request. So let's go ahead and copy this into our alert, or actually, so instead of an alert, now we're going to do a fetch, right? And hopefully this will send our payload to the right place. We'll check it in a second. Is it command V?
Command, yeah.
Okay. Goddamn map. Yeah, I did not copy it, did I? Okay. All right, so as it stands right now, the button on click will call the fetch function with the argument of the URL of our post bin, right? And you might notice like it's got this extra question mark at the end, and then it says hello equals world. If you're doing your whole HTTP request within a URL, you can add additional query information using a question mark and then setting fields like the field equal to whatever you want to fill it with. It's like not good practice to do that because like all of your form fields would be exposed like if you sent a lot of requests like that. So like if you're making a web application with a form, try not to send it to your server that way. But for now, we're just sending it to our post bin, so it's okay. So I'm gonna go ahead and update this, and then we'll click the button. What do I? Yeah. Okay. I'll go ahead and click the button, and so nothing happened. Clearly, it's not doing an alert anymore. But we can go ahead and check the post bin. Let me reload this, and you can see that we got a request from somewhere. It's not really telling us much. So it came from Stephen Calleyman. So we know it came from the right site on a Mac. You can see the user agent is Mozilla. We are in Chrome, but a lot of browsers will be identified just as the same. And so it said hello world. And so to get the cookies, there's not much we have to change for this payload. We can, because if you remember, the cookie said secret number equals. So that's already in the right format. So we can just append document.cookie to the end of this payload right here and then click update. And then we'll try clicking the button again. Hopefully that sent the request. And if we reload it again, you can see that now we have a new HTTP request that came in with our secret number of 82, right? And so that's sort of a general idea of how XSS works. Anything that takes user input doesn't completely filter it properly and allows JavaScript to be injected, which is why it is considered an injection vulnerability, is a possible victim for cross-site scripting. And as you might have figured at this point, cross-site scripting is a big deal because of the potential to leak private user information from one person to another. Yeah.
My turn.
Okay, where's the slide?
It's over there. You look up the tabs. Okay, so Stephen introduced XSS, kind of showed us what it does, but let's get a more formal definition. Let's figure out some types of XSS, how they're different, so we can classify different kinds of attacks and what's bad about them, where the vulnerability lies. So what is XSS? We'll get it on paper. It's a type of injection attack that involves injecting malicious scripts into trusted sites, kind of like Stephen showed. It's much more arbitrary than SQL injection. SQL injection is more querying a database. This is JavaScript code. It can do whatever we want it to do if it gets injected. Why is it bad? We already saw that. The attacker can often impersonate a victim using a session cookie. It can carry out attacks actions as the victim, so it can impersonate them. As I already said, it can access the victim's data in the cookie, like Stephen already showed us. And this is obviously a big issue if the victim is an admin or is anyone in some kind of position of power in that particular web application. How is it carried out? We saw Stephen typing it into a form field, but we can have it do all kinds of different things. It can come from lots of different sources. So the attacker uses a web application to send malicious code to different users. This could be from a URL, from any of numerous sources that we're going to go over. And the user's browser doesn't know that it shouldn't trust this code, shouldn't trust this script, and just runs it. It doesn't ask questions, says, well, I trust the site, therefore I trust the script. Let's do it. It's obviously a problem. And this is often done by manipulating a trusted site. So the site itself returns malicious code. That's called a stored XSS attack. We'll go into that. First, let's go into some types. So the first type is reflected. That's the simplest. That's where the actual XSS payload is in the URL. So you actually can embed a script in a URL. You can send it to someone and say, hey, click for free money. They click on their URL and lo and behold, you have an XSS script in there. So that attack deals with an immediate response. Stored XSS is where a payload is stored on a web server in, say, a comment or a forum post of some kind. And the attack is in a later response when some other user renders that page. And then a DOM-based XSS that results in arbitrary code execution on the client's browser. That's more of a client vulnerability than a server one, but we'll go over that. And that has to do with both reflected and stored XSS. So reflected XSS, I kind of already introduced. It's where the application receives data in an HTTP request and immediately includes data in a response. It's often done through a URL with an embedded script. And this happens when a site performs little to no processing on its return data. It lets this attacker run an arbitrary script in the server on the site, kind of a problem. And the attack is carried out when a victim visits a URL constructed by an attacker. Again, some kind of phishing email. You send a link to your buddy. I'm hoping you're not going to do XSS attacks on your buddy, but they click on that link, bad things happen. That's when the attacker script executes in the user's browser and does all kinds of things that Stephen already demoed. Stored XSS, as I kind of already mentioned, is where the attack is stored on the site and sends out that unsanitized user input, a script of some description in dynamic content. Again, comment, forum post, video, whatever you want it to be. The application gets data from the attacker and includes that unsanitized data within later HTTP responses. It's like laying a trap for people to come and step on later. Data is often submitted via HTTP requests. So like I said, all kinds of things, names, a customer order, comments, anywhere that the user has control of the input it could come from. And it happens when the victim visits the site to retrieve and execute that code unknowingly. Again, the victim doesn't have a choice as to whether or not that code gets executed often. It's their browser just says, well, it came from this site that I trust, therefore I should run it. Leads to bad things. DOM-based XSS is a little bit more complicated. So DOM itself stands for Document Object Model. It's part of the HTML makeup of a site. It occurs when an application contains client-side JavaScript that processes data from an attacker in an unsafe way. So think eval or inner HTML, where you can actually pass in text as code and run it as code. This is more of a client-side vulnerability than of the website itself. So the attacker needs to place data into a source that will be propagated into a sink being something that allows for that dynamic code execution on the fly. This is typically in the URL, as with different attacks. It's just that it's classified differently because the vulnerability lies in a different place. So you might say DOM sounds a lot like reflected XSS. It's in a URL. Like, how are those things actually different? So in reflected XSS, the attacker's payload is part of the request sent to the server. It's part of an embedded script. And the attack actually, the attack itself actually happens when data is included in the immediate HTTP response unsafely. Whereas DOM-based XSS, the attacker's payload is written to the document object module. So the data never has to actually go to the server in this particular attack. So the attacker's data gets written to a sink and executed. No server, no HTTP requests necessary. It's a bit more complex, so it's rarer, but it happens very different. One involves a response from the server. One involves just that link doing bad things on the client's machine. So more recently, we've seen XSS attacks classified in more of a client server setting. So instead of doing reflected, stored, and DOM-based, it actually describes where the vulnerability is. And so you see some overlap. So a server XSS attack is when the vulnerability is with the server. Untrusted user data is included in a response from the server from any kind of request. A source could be a request or a stored location. So you see both reflected, as I said earlier, use the URL, get an immediate response, or stored server XSS. And the entire vulnerability is on the server, whereas client XSS is more kind of that DOM-based, as I mentioned, where untrusted user data is used to update the DOM in an unsafe JavaScript call. Source could be from the DOM or the server. So you could actually have client XSS that's a combined vulnerability of the client and the server, but at least part of it has to be from the client. And the ultimate source of the attack is from a request or a stored location on either the client or the server. It's really muddy. You can have attacks that are both. Part of it's on server side, part of it's client side, all that. So as I mentioned, you can have reflected client and or stored client XSS. Yeah.
For client XSS, wouldn't you have to like have the client's computer in front of you in order to not like access the server?
Not necessarily. It's like I said, where a client could use a link that could actually update the DOM itself via a script instead of posting a request to the server.
So the link doesn't actually take you to any websites, but it just updates the page?
The attack happens before the request is sent. So the vulnerability is not from the server. It's from that browser executing that script before the request is sent. So that's the issue with the client side. So how do we stop XSS? As with all kinds of injection, it often has to do with input validation and using the right things where, and never trusting user input with much of anything. So the main thing is context sensitive output encoding. It's where data is encoded for the actual context where it ends up. So we escape all kinds of dangerous characters. We encode them differently. We really need to make sure that all these things as user input can't be used as code anywhere, irrespective of our initial intent for where that input's going. Input validation and data sanitization are also important, but mainly that context sensitive output encoding is what's going to stop it ultimately. Client XSS, largely the same. Using safe JavaScript APIs when you develop your sites for the JavaScript that's run on people's machines is important. This can be pretty hard because it's difficult to say, I'm going to read through all of the source code on this API every time you use one. So as a backup, also using context sensitive output encoding in that setting is relatively important. And now I will hand the reins off to Jerry to talk about CSRF.
All right. So for the second part of this workshop, we're going to talk about CSRF. This is really closely related to XSS. In fact, it shares the same first two words. So XSS was cross-site scripting. CSRF stands for cross-site request forgery. So because it has cross, like cross-country is sometimes XC, it's sometimes also known as XSRF. This is pronounced CSRF or CSRF. You can pronounce it both ways. And this exploits a website's trust in the browser. So we're going to explain like the fact that it's cross-site means that you go to a different website, but it launches an attack on like the original website and it forges a request. So it's not a request that you send, it's someone else's request, but you still unknowingly send it. So TikTok, YouTube, McAfee are all companies that have gone under CSRF attacks. So this is a very big thing. Now it's not as big because of something called CSRF tokens, which we'll get into, but before it was something very, very major. So this is a quick little graphic to show you how a CSRF attack is done. So first, let's say you log into a bank and you log in with your credentials and the bank web app saves your credentials, maybe in the form of a cookie or a token in your browser. So that next time when you visit that bank website, you don't need to log in again. It could be also like something like save password. And then later, some malicious devil dude creates this evil web application, and then you visit it unknowingly. So maybe they sent you an email and they're like, oh, free money here. And then you click on it. So you visit that evil web application. That web application tells your browser to post this to the bank. So that's one of the HTTP requests. It could be a post, it could be GET. It just sends a request to that bank. And because your browser has that cookie with that saved credentials, the bank application will believe that you sent that because cookies are sent automatically to the server. So when that happens, maybe that person creates a request that transfers money to him or herself. So that is very, very good for them and very not good for you. So here, let's go to a demo. So you guys can follow along if you want. This is a link to something called Definitely Secure Bank. You can tell by its name that is obviously secure. So let's say you create an account, ABC, and then you have some random password. So you can go inside. Chrome tells you that it's probably not a secure website. So you can definitely tell it's secure. So you can see it says, welcome back, ABC. Your account balance is $20,000. And if you were to like close this tab and then you visit this tab again, you can see that like you don't have to log in again. It saves it in a cookie. And then let's say you want to make a transfer. So you make a transfer, let's say to $10 to, let's pay money to Josh to bribe him for something that we don't know. But if we transfer for information on the challenges, so if we do that, we can see we lost $10. It's now $19,990. And it tells you who it's to and what the description is. So let's look more at like how this happens. So if we inspect element, we can go to, what is it, application, memory, network. Yeah, we can go to network. So let's make another transfer. Let's say $10 wasn't enough. Josh is greedy, so let's do $30 this time. Bribe times 3. And then we submit that transfer. We can see that a new request pops up. So we click on this, we can see that this is the URL that it transfers to. It was a post request. It was accepted, which is why it has a request code of 200. And then if we scroll all the way down, you can see like the description. It says to Josh. I don't know if you can see it on Zoom, but there's like a form data. It says amount 30 to Josh and description bribe times 3. If you click view source, you can see it in kind of like the form that you could see in a URL. So amount equals 36 ampersand 2 equals Josh ampersand description equals bribe times 3. So that's basically what's going on whenever you do this. And you can see it's really easy to like copy and paste this request and maybe change some of the numbers, change where it's going, stuff like that. So let's see how that could happen. So you're checking your email, blah, 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 blah. You see this email that says free money. And it's like, hey, here's a cool link that you should click on. You can get $100 if you click on it. So you decide to click on it because that's who you are. You trust random links that people send. It's like, yeehaw and welcome all surfers. There was a typo in my email. Congrats on winning negative $100. Check your bank account to double check. You're like, how does this happen? This is a completely different website, unrelated to that bank account at all. So you go to this bank and lo and behold, there was a negative 100 to evil scammers just for loading that website. So you're like, how does this happen? Before we get into how this happens, let's look around on this website a little more. If you're cool, click here. Since I do not chicken out, let's click it. Now let's see what happens on the bank account side. Oh no, we lost $200 more just for clicking that button. Interesting. Let's see, this is a cute picture of a dog. Let's click on the dog. Let's go back. And let's check it out again. Oh no, the dog stole $200 from us just for clicking on that image. And then because we went back, we reloaded the website and we lost $100 more just from that. So that was a lot of money that we paid just to see CSRF in action. But now let's see the code that runs. So if we inspect page over here, or I guess it might be easier for me to just show the backend code. So this is the backend code for that website. This is just like style stuff, blah, 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 blah. And this part is like the interesting part. So you can first see here is a script tag. It creates a variable body with search parameters, amount equals 100, description equals loading website, and 2 equals evil scammers. So you can see they basically took that request that we saw when we inspected element on that bank account page, and they changed the numbers and the description. And here is that fetch command that Stephen was talking about earlier. Fetches that, it uses a post method. So this script runs whenever you load that website, which is why every time we reloaded, we lost $100. We can also include JavaScript on buttons. So here, button on click, and here's something that runs on click. And then even if you click on like an image on click, it has like something similar. You lose $200 to the evil doggo. So yeah, that's basically how a CSRF attack is executed. Okay, so let's go back to the slides now. Oh yeah, disclaimer, this was not built by me. This website was not built by me. My name is not Victor. So yeah, so let's recap what happened. So first, the hacker identified the request API on the bank account website, and they forged a malicious one. It basically just pays money to the hacker instead. The user logs in, and the browser stores the cookie inside like the browser. The hacker sends that malicious API to the user to run, and this was on a website. The hacker sends the link and the user clicks on the link and the browser runs the JavaScript automatically. The user runs the API, uses the cookies to authenticate. So the cookies are sent automatically and then they lose a lot of money. So what went wrong? A lot of things went wrong in that series of steps. First of all, the API was really easy to recreate. It was a get or a post request. There specifically, it was a post request, but get requests are even easier to recreate because they're in the URL. The user also clicked on the malicious link that they probably should not have trusted. One other thing that went wrong is the browser stored the cookie that bypasses authentication. So let's say you have something in your browser, like a setting in your browser that says, like, whenever you go to a bank account, don't store the cookie. That would have saved you from the CSRF attack. And then the last thing is that the request did not contain any authentication. There was nothing like a token to confirm that this request came from the bank website and not the website with the dog. So yeah, moral of the story, don't click on evil links. So now, I mentioned this earlier, now there's something called CSRF tokens. This is why CSRF is basically irrelevant nowadays. So server will send randomized tokens to the website. So just the banking website for every request. And the banking website will send that token back to them to confirm, yes, I am the banking website, and this is a legitimate request. So you can think of it kind of as two-factor authentication. And so if you're a hacker, you make a different website, you don't get that tokens from the banking server. So you can't send forged requests because you don't have the tokens. Yeah. So now let's compare XSS and CSRF. Both of them inject JavaScript, which is why they're now included in the injections. But XSS injects JavaScript so that the server runs the code, whereas CSRF injects the JavaScript so that the user will run the code. And XSS requires a vulnerability in the website, like a text field that was improperly sanitized, whereas CSRF requires no vulnerability in the website. In fact, it requires vulnerability in the browser and like the APIs between the browser and the server. And if you're able to do both XSS and CSRF, then you can basically run JavaScript on both the server side and the user side. And that can be very, very, very dangerous. CSRF is becoming less and less common, but if you go on old websites, you can still find vulnerabilities all the time because people don't like to update their websites. So this is the story of one of the most famous viruses. I guess you can call this a virus of all time. This is called the Sammy worm. So back in, I think 2005, MySpace was a thing. Facebook did not barely existed yet. So back then, MySpace was susceptible to both XSS and CSRF attacks. So this dude named Sammy, he created like this really, or I guess it's not super long, but like a sizable chunk of code that he posted on MySpace. So that code will, if anyone views his profile, then they're going to send a friend request to him. They're going to update their profile with that same code. And it's going to also read, but most of all, Sammy is my hero. So basically in 20 hours, Sammy was able to receive 1 million friend requests on MySpace. And it is the fastest spreading virus of all time. It's like 20 hours, 1 million, like even COVID isn't that fast. So he used both XSS to send the JavaScript to other people because he inputted that onto his own profile. And he used CSRF to change the users' profiles because the users had to be logged into their MySpace account to be able to like change their own user profile. So because of that, he received 3 years of probation with only 1 computer and no access to the internet, 90 days of community service, and 15,000 to 20,000 in restitution. So before you perform attacks on that, on like very big websites, make sure it's legal. Yeah, so I think that is the end of our workshop. Thank you guys for attending. That is the attendance code. And I think our workshop challenges should now be up. Right. Wow. Well, are our workshop challenges up?
Yeah. Yes, they're
Cool. Yeah. So you guys can go do the workshop
If
challenges.
anybody has any remaining questions, feel free to ask at any time.
Yeah.
Check the chat.
Cog, thanks. Get wrecked.
It's all
Thank
It's just.
you, Josh.
Should we stop
Wait.
recording?
Oh yeah.
Who was the guy in the jazz chat? It was like Mike.
What is it?